Hello everyone, welcome to More Fun with Prime Numbers. In this course, I invite you to the mysterious world of prime numbers. I will talk about prime numbers from the classical theory to recent advances. You will learn many interesting properties. You will also see many challenging unsolved problems. Some of you may feel mathematics is a little bit difficult. Don't worry. If you feel some part of this lecture is difficult, please take a pencil and paper and calculate. Then you can be a friend of prime numbers. As you take this course, I hope you will find many interesting topics on prime numbers. I also hope you will challenge unsolved problems in the near future. Let's start the first lecture. First of all, let's recall the definition of prime numbers. Recall that an integer n greater than or equal to 2 is a prime number if it is divisible only by 1 and itself. Let me explain them using a prime number ruler invented by Kyoto University. For example, 2, 3, 5, and 7 are prime numbers. 11 and 13 are also prime numbers. Here is a list of prime numbers up to 100. Prime numbers have many interesting properties. There are many deep theorems, conjectures. Also, there are many open, unsolved problems. In this course, you will learn both theory and practice of prime numbers. In the first week, you will learn basic properties of prime numbers. In the second and the third week, you will learn nodes of prime numbers. Then, in the fourth week, you will learn practical aspects of prime numbers. Prime numbers are applied to cryptography today. Finally, in the fifth week, you will learn recent developments and open problems. There are many interesting, important, and challenging problems. I hope you will enjoy the lectures. After taking this course, you will become a master of prime numbers. Let's begin with one of the most important properties of numbers, which explains why prime numbers are so important. This theorem is called prime factorization. Every integer n greater than or equal to 1 can be written as a product of prime numbers. Namely, n can be written as the product of P1, P2, and PR. Moreover, the prime numbers appearing in the product P1, P2, and PR are unique up to permutation. For example, 36 is written as 2 times 2 times 3 times 3. But it is also written as 2 times 3 times 2 times 3. You can see that prime numbers appearing in the product are independent of the decomposition. In some senses, prime numbers in mathematics are similar to atoms or elementary particles in physics. By this reason, prime numbers are very important in mathematics. The fundamental question is, how many prime numbers are there? The answer was known more than 2,000 years ago. An ancient Greek mathematician, Euclid, proved that there are infinitely many prime numbers. We can make an arbitrarily long list of prime numbers. We can continue writing prime numbers. But the process never stops because there are infinitely many prime numbers. Let me recall Euclid's proof. Let P1, P2, and PR be a given set of prime numbers. In order to show there are infinitely many prime numbers, it is enough to show there is a prime number outside this set. We consider the integer m, which is the product of P1, P2, and PR plus 1 by unique factorization m can be written as a product of prime numbers. Assume that m is equal to Q1, Q2, and Qs. Let's look at the prime number Q1. M is divisible by Q1 by the second equality. But M is not divisible by P1, P2, and PR by the first equality. Therefore, Q1 is different from P1, P2, and PR. Now we have proved there is a prime number outside any finite set of prime numbers. This proves Euclid's theorem. Now let me tell you a story about prime numbers. Alexander Grothendieck was one of the most influential mathematicians in the 20th century. He developed many deep theories. Today, many great results on prime numbers are based on his theories. It is said Grothendieck's way of thinking was too abstract and conceptual, and he usually did not consider concrete objects when he created his theories. One day he was asked, "What is your favorite prime number?" Then after a short silence, he replied, 57. Of course, 57 is not a prime number because it is 3 times 19. I'm not sure this is a true story, but admiring his achievements, people call 57 Grothendieck's prime.